Welcome everyone. We have two more interesting presentations. Let me announce the title of the presentation. It's a Simulator Independent Enhanced Centralized Regression Optimization Toolkit for Expediting Regression Closure. Harshal Kothari from Samsung will be presenting this. Before we start the presentation, let me kindly remind you to please complete the poll and send your feedback. We will have a 5 minutes question answer session towards the end of the presentation. Thank you. Over to you, Lavina.
Hello everyone, I'm Pavan from Samsung Semiconductor India Research and Development Center. Today I'm presenting on the topic Simulator Independent Enhanced Centralized Regression Optimization Toolkit for Expediting Regression Closure. First of all, congratulations to everyone who's presenting, and I would also like to thank my co-authors and the entire DVCon India team for giving me this opportunity to present. The simulation time depends on the size and the complexity of the design, the test bench, license availability, and the simulator performance. Along with RTL simulations, we'll also have X-propagations, power-aware simulations, and gate-level simulations. With increase in number of subsystems and IPs in an SoC, total number of tests increases exponentially, thereby increasing the net runtimes and then the license availability. So the agenda of this presentation is to discuss each of these concerns by managing the regression progress, and then thereby bringing the runtime and then the resources, which will eventually bring down the cost of the project. All this done without bringing the efficiency of the regression. So the toolkit employs three main aspects to expedite the CR process. The first is live tracking. Next, there's the simulation speed, and then the license and compute optimization. Next, we'll also look into how much cost will be cutting down by using this toolkit. Moving forward, we'll be looking into the tool's impact in the gate level simulation. Lastly, we'll see the whole process of the tool and its future scope. The logistical challenges while running a centralized regression were automated initiation, live report presentation, easy tracking and debug of failures, and coverage. So once the design release is available, the tool analyzes the test plan spreadsheet and then creates a comprehensive list of compiles, elaborations, boot snapshots, and the tests to be run. So once the tests are launched, the real-time regression report and then the merged coverage report is generated in HTML format with customizable refresh rate. So the HTML has the capability of triggering the coverage merge based on the list of tests which the user provides of its own interest. In this section, we will discuss on the features of live tracking, which is the HTML dashboard, the smart coverage merging, the owner summary, job summary, pre and post processing. All of the process is automated from start to the end. This is how the top level of the HTML web dashboard looks like. So once the tests are launched, the complete regression can be tracked by this automated HTML. The HTML gives an hierarchical summary of the whole SoC. So on the top, the whole SoC's summary is given, and each block along with the total number of tests, pass, failures, stopped ones, and then the gives an idea of the number of compilation issues in the block and the test incompletes which are due to the license or any other tool related issues is also summarized. So this gives a picture to the owner of the block or the manager for which block to be prioritized. And along with that, there is a links given for owner summary, job summary, and coverage summary. There is an also feature called archiving, where we can directly access the web page of previous regressions directly through any web page. One step lower in the hierarchy, the owner can find the details about the block. At the top, we can see the block summary. It shows all the IPs in that block and its individual pass, fail, running, waiting status, and the owner name who's verifying the IP. So average runtime of each IP along with long running test cases, which can be set based on the project. Maximum and minimum runtimes are part of the dashboard. Abnormalities can be identified and looked into. It summarizes how many failures due to compilation issues, tool issues separately. So too many failures in these categories need immediate attention. So this is how a IP summary looks like. For each IP, it shows all the test cases and its status. All the information needed about the test case, it's like its run path, job ID, failure reason, how much time the test ran, the start time, end time, along with displaying the paths of the log. It also captures the warning, errors, and dumps it to a separate file, which can be accessed from the HTML itself through that link. It saves a lot of time for first stage analysis. So already known error can be fixed immediately. Like it saves a huge task like skimming through the log. From any page of the HTML, we can go to home page by directly clicking on the home button. The next feature is the smart coverage merging. So as the test with coverage enabled complete, its coverage is merged and published in the HTML. This saves a lot of time for engineers having to run at their end and merging the coverage. And this also saves licenses. So there are two features in that. One is incremental coverage merging, which saves time and space, and only IPs of our interest and hierarchy can be merged. So there is a flexibility to add waiver also, coverage waivers. So they are considered separately by the tool and they are published. And generally 20 to 30% of the tests contribute to 75 to 85% of the coverage. After the first regression complete, the tests which were ranked to extract the list resulting 80 to 85 coverage. So in the subsequent, we don't have to run all the tests to hit the coverage. We know like the majority tests which we have to run to get the maximum amount. And from the image, we can see that IP name is shown and then the coverage before and after the waivers. So if you click on the IP, the complete list of the signals are shown, and then like it shows whether the signal has been hit or not. So this saves a tremendous license cost and issues which can arise when multiple people work on coverage analysis at the same time, creating license crunch and reduced efficiency in analysis. So the next is the owner summary. This is quite handy for the managers. So a separate owner-wise summary is available. It allows them to track the regression results with owner-wise progress and IPs. So any discrepancy can address, and also owners can directly access all their IPs at one place. So even irrespective of which blocks they are spread across. So the next feature is the job summary. A detailed report of number of jobs launched each day is been recorded and reflected on the job summary. It encapsulates the number of passes, fails, running jobs on each given day. And most importantly, it shows the average wait time and the resource acquisition time. This will tell us if there was a license crunch on a particular day or not. So one more thing is it also lets us track the disk space usage and sends email alerts, so we don't run into an issue when the disk runs out and causing the test to fail and wasting resources. In pre-processing, even before the start of regression, the test vectors are gathered from the test plan and are analyzed for its correctness. The wrong test vectors are simply goes through and acquire license and end up failing. So this way, the human-made errors can be analyzed even before the start of regression. So with this, with very few iterations, we can attain 100% pass rate. And very few important tests are selected as smoke tests. So these smoke tests are launched when a major only these few tests are launched when a major RTL changes is taken place. So like for example, instead of running 300 tests, one test is selected as a smoke test, and that test is run. If that fails, that means the rest 299 tests also end up failing. So this way we can avoid using of more licenses. In post-processing, we can update the filter for failure categorization at any stage of the regression. So comprehensive checkers and filter files are developed in order to have zero fake passes, which can lead to a potential bug in the silicon. There are known for fake failures also as well in the filters. So this results in saving engineers time when it is reported as a failure, but actually the tests are passing. The next feature of the toolkit is dealing with the simulation speed. So we have three optimizations to deal with. First is the profiling. The second one is the auto analysis and the performance knobs. And the final one is the save and restore. In profiling, we use the Cadence Xcelium simulator memory profiling to analyze the major contributors utilizing the simulation resources, identify avenues for optimization like always on clock assertions, poorly written HDL code, and design logic consuming high memory to execute. For instance, simulator dependent XM mirror was being used in multiple places, which is an expensive method. There are multiple clocks being used across various checkers, which caused additional overhead. So we have changed the usage from XM mirror to assign the statements to reduce this, and we were able to improve the runtimes by 1 to 2%. With overall profiling, average runtimes were alleviated by 5 to 6%. SimSpeed auto analysis was used to perform an in-depth audit of the options used during the elaboration and simulation stages and identify the switches causing the bottlenecks and eating simulators efficiency. The debug access authority was provided only to few instances and modules. The performance switches along with the latest tool versions resulted with the improvement in elaboration and simulation times by 15 to 17%. By making our verification entity compatible with the save and restore flow, we could able to bring down the average sim time by additional 50%. So in SOC simulations, the basic boot, clock, power, and memory initialization are required to bring up the design for further testing of each IP and block. So making the snapshot of the boot sequence as the base and using it to run our tests, it resulted in saving 4 to 6 milliseconds of simulation time for each test, with average 2,500 tests in an SOC regression. We were able to bring the turnaround time reduced by 47 to 54%. The next feature of the toolkit is the LSF optimization. Generally, there'll be two runtimes. One is the estimation time, which can be calculated from the regression logs based on the LSF utilization, and then the actual runtime obtained from the regression based on the start time and the end time. Ideally, these two should be very close to each other. However, various factors involved in LSF job scheduling and license acquisition mechanism result in the variation of the actual time. And LSF profiler and analyzer script was developed to aid in tracking and projecting the LSF scheduling, and then the license acquisition mechanism. This profiler monitors the status of the running jobs periodically and dumps out the logs report for analysis. With this regression profiler, we were able to get turnaround time between 15 to 25%. The LSF utilization improved significantly from 84% to 97%. and license utilization improved between 25 to 40%, resulting in huge cost saving and effective utilization resources. From the table, we can see improvements after all the optimizations of about 57% after incorporating all the above discussed enhancements and in our toolkit environment. And also this is project agnostic, that is, it's project independent and can be extended to any IP or SOC DV. This pilot has been successfully implemented in our current SOC DV project, and it shows a tremendous improvement over traditional regression approach which was used before with our live time tracking and reporting and simulation speed enhancement and license optimizations. The improvement done raised a curiosity to document and quantify the amount of cost we are saving. Typically, we come across SOCs with the average tests of 6,000 test cases and running for average time of 24 hours. So during the whole cycle of the project, we run typically around 14 iterations of centralized regression. And we use close to 10 to 12 different licenses for different IPs, probably like VIP licenses, PCI licenses, and then enforce, which has an average cost of around $25. So this table projects the cost estimate for the licenses with and without optimization. From the previous table, we could see we got a net improvement of more than 50%. So here we are taking 50%. This brings down the average runtime of the SOCs to 12 hours. Now we can see the average cost in USD coming down by almost 50%. This is case for one project. So from here, we can see we are saving close to $1.5 million on one DV project. So consider this used entire Samsung. Typically, there will be like hundreds of DV projects being executed parallelly. The amount saved will be humongous. So the tool as a package has a huge impact on saving the cost across the organization. Pre-gate level simulations, that is the unit delay simulation with netlist, takes high time to complete, and timing GLS takes even more time due to the SDF compilation and the back annotation. So using the above optimization techniques in GLS showed an efficiency in bringing down runtimes by around 25 to 35%, which saved around 10 days of time. This table shows the reduction of total runtime when using profiling, auto analysis, and save and restore techniques. Although the number of tests are less compared to RTL simulations, the toolkit development for GLS is very crucial, as the turnaround time for the same test is considerably higher. Like for example, if we have a test that takes around 1 hour in RTL simulation and compile and elaboration is half an hour, the post netlist, it takes 6 hours to just compile and elaborate, and takes around 8 hours to complete the simulation, which is depending on the resource available. Thus, the improvement introduced via the toolkit regarding the total time taken for the simulations make it very important to achieve 100% regression before the tape out. This is the flow of our toolkit. The test vectors are directly taken from the exhaustive test plan. These test vectors are first run through the pre-processing scripts to check the initial errors. A complete list containing the builds need to be run for this regression is generated. In this step, we need to enable the coverage and hierarchies we are interested in. We can also choose which blocks to prioritize and whether to run the full regression or smoke test. In the next step, the build list is launched by the tool. Once the compilation and elaboration step is completed, the tests are launched in the vManager. As the tests progress in parallel, the live HTML progress is been shown along with the merging coverage with other summaries as well. So once the regression is complete, the profiling and the LSF optimization is done to analyze if the regression can be, the time can be reduced further. After taking the changes into consideration and fixing the test plan errors, the next iteration is started. We are planning to make few enhancements such as killing SNR jobs early on if there is some discrepancy with the work lib snapshots, and then make few enhancements for the HTML, make it more interactive and better GUI. And we will also like auto rerun the test of known failures, which will go through if we rerun it again. With the centralized regression optimization toolkit development, in the in our DV project, we were able to save close to $1.5 million on just licensing costs for one project, and close to 200 net engineering hours of all the our DV engineers with this enhanced GUI. Yeah, that's all. Thank you so much. Any questions?
Thank you, President. Thank you, Pavan. I have received one question. Let me ask you, the pre-processing which you had described in your flow, how does the tool determine the correctness of test vectors? Or does it determine the correctness of test vectors?
Yes.
The pre-processing part.
Okay. So in our test vectors, there can be typo errors. Probably like 2 hyphens, and we generally in Samsung we follow something like mcons, so which runs through that, and then if there are any typo errors, it will try to find that out, and then there'll be few switches. So the switches, everything will be predefined. So this in the test vector, it goes through all the predefined switch list, and then it tries to find if there's no match for a particular switch, it will be typed, it will be categorized under failures. So that will that all the failures will be printed in a log separately, and then when we open the log, it will let us know whether this is categorized as a fail, and then what failure reason it will give, something like that.
Okay, so test case artifacts it detects early.
Yeah.
Okay. Okay, we have some time. I have one question also. You had talked about the future work. Do you already have something implemented or plan to implement where you mentioned that it can also look at the past regression, where it looks at not only the past regression, but also checks what kind of failure was there in past regression and what was the outcome of that. In other words, if there was link it to the JIRA system where there is a issue already root cause that this is a test environment artifact, this can be ignored, or this is already fixed, but the bug is still reappearing. So just to summarize, a long question that I'm asking is linking to the JIRA, linking to the past fail analysis. Is this already built in the system, which you missed to mention, or is this something you look at it as future work?
So with the JIRAs, there is a plan to link with the JIRAs. For now, what we have done is the email. We have developed a system where automatically the tool sends an email for the failures. And then once the one iteration is done, so we can probably add if there's something categorized as a failure, and we know that failure, each failure have a particular name. So if we add that failure to ignore that this thing, the tool from the next time, it won't categorize it as a failure. So all the remaining failures now, there's a system where the email is automatically sent from the tool to the particular owners. So that is there, but with the JIRA, we are still in progress.
Okay, and
that is the plan is there currently.
Okay, and the owner is not the owner who runs the particular test case, but the owner of that particular module.
Yes.
Okay.
So there will be generally one guy who handles central regression, and then the owners of the IPs.
Understood.
Yeah.
Thanks a lot.
Yeah. Thank you
so much. Thank you very much for the good presentation. I do not have any question received so far, but we can give it some time.
Okay. Yeah. Okay.
Actually, we are pretty much done. So we are running, checking the time. We're running out of time. So once again, thank you, Pavan. Appreciate you taking time to present. To the audience, kindly do not forget to send your feedback, the poll for the presentation.
Yeah. Thank you so much. Thank you so much, everyone.
Thanks. So we